Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-1 lesson on simplifying rational expressions. And as the title indicates, that is exactly what we are going to do. Simplify things that have a polynomial in either the numerator or denominator, or both. We're going to begin this lesson by exploring one of the more misunderstood concepts of canceling out. So, what does canceling out actually mean in a fraction? I mean, we've probably done it before, but in which situation below are we actually allowed to cancel out the x's? And why? Pause the video, contemplate this, maybe write something down, and we'll bring it back together. All right, so maybe you figured out that 3x over 5x was the situation where we can cancel, and this x plus 3 over x plus 5 was not. But why is that the case? So let's define what canceling out actually is, and then we'll see. Canceling out means we are dividing a number by itself. Because this is what's happening when you cancel out, it's actually division. We can only pull off canceling or even just reducing a fraction if we can unmultiply a factor, the factor that you're canceling, into its own fraction. So just to show you what I'm talking about, let's talk about this 3x over 5x where we are allowed to cancel. Now the long way of doing this would be to split this up into two fractions. 3 over 5 and then x over x, and we would be multiplying these fractions together. Now this is legal because if you multiply these fractions together, we know that we multiply straight across, so this would just be 3x over 5x. So because that works, we're allowed to go the other direction and unmultiply. But wait a sec, what is x over x? Oh, if you divide something by itself, that's just 1. And 3/5 times 1 is just 3/5. So we've essentially gotten rid of these x's, but the reason we were allowed to get rid of them is having these here, we were just basically multiplying by 1. Now the short way of doing this, because this is kind of the long way around and kind of a pain to do that every time, the short way would just be to take the original expression and just cross off the two x's like you're used to doing, and then just write this equals 3/5. But really what's going on behind the scenes is this taking the x's into their own fraction. Now, because this is what's actually going on, this explains why we cannot cancel out the x's in this first fraction up here. We can't write x over x times 3 over 5. Well, for one thing, we're not multiplying x and 3 and x and 5. We can't split it up into addition either because we can't add straight across. And even if we could write x over x plus 3 over 5, that would be 1 plus 3/5, which is not the same as 3/5. Any way you slice it, canceling out is only going to work in a situation like this where the things you're canceling are being multiplied, either by some other number or by an invisible 1. Now that we've talked a bit about the idea of canceling out, let's go ahead and simplify this rational expression. Oh, but wait, let's actually back up for a moment and define some of the things we're talking about here. For example, rational expression, what does that mean? Well, it has the word ratio, which means to divide. So a rational expression is a quotient. It's a quotient of two polynomials. So if you have a quotient that has things that are not polynomials, you might have some kind of weird function, but it's not a rational function. All right, so what does the idea of simplifying a rational function mean? Well, it means really two things. For one thing, we should only end up with one fraction when all is said and done. Now, all the problems in this lesson are just single fractions, but later on you'll see a few where we're either multiplying or dividing or subtracting or adding fractions, so we want just one fraction. Also, we don't want to have any common factors, so no common factors between the numerator and the denominator. So basically fully reduced. So let's go ahead now and simplify this thing. Now, since we're not supposed to have common factors, that means we need to know what the common factors are. And in order to know what they are, and really we've seen that we have to have multiplication to cancel things out anyway, we need to factor before we cancel anything out. So let's go ahead and factor the numerator and denominator. So for the numerator, we always look to take out a common factor first. Looks like we can take a 3 out of this. So if we do that, we're left with an x and a minus 5 inside. And now for our denominator, we can take out a 6, leaving us with an x and a minus 5. Once you've got things fully factored, obviously cancel out common factors, but also make sure you reduce coefficients and like bases, bases that have the same base and maybe different exponents, maybe the same. You're just using your exponent rules. So here we have some coefficients we can reduce. 3 over 6, that reduces to 1 over 2, so that's just normal reducing math there. And like before, you don't have to write the invisible 1, but it's there. And now these x minus 5s, those are the exact same factors, so we can now cross those off. You're basically dividing x minus 5 by itself. And what are we left with? Well, in the numerator, it looks like we've crossed out everything. If you've crossed out everything, remember, you're really just turning these into 1s. So you still have at least a 1 in that numerator. And in the denominator, all that's left over is this 2, so we end up then with 1 over 2. And that is fully simplified. One fraction, no common factors. Here's another problem with, in some ways, a little bit more going on, in some ways, a little bit less. Pause the video and see how far you can get on this one. Now, hopefully you remember that the first step is to always try factoring out before you cancel anything out. So we can't do anything with the numerator. That's still going to be 8x cubed. That's as good as it gets. The denominator, though, it looks like we have a common factor of 10 between the 10 and the 80. And also for the x's, we can take out an x to the 5th. That's the smallest exponent. So 10x to the 5th. If I take that out, then 10x to the 6th is now just going to be an x. And 80x to the 5th, I can turn that into a plus 8. There's nothing I can do with this x plus 8. There's no x plus 8 upstairs that I can cancel it with. However, the rest of this stuff might cancel. So the 8 and the 10, those can cancel together. I can actually reduce those to a 4 over 5 if I reduce those by 2. And for the x cubed and the x to the 5th, we can do something with those as well. If you divide those, we're really subtracting the exponents, and whichever side had the higher exponent gets the result. So 5 minus 3 is 2, so we have an x squared downstairs. And now let's put it all together. What's left in the numerator? All that's left is this 4 that we wrote here. In the denominator, we have a 5 times x squared times the x plus 8 that was already there. Okay, so we saved the best for last, final boss battle. Pause the video and see if you can use some of your advanced factoring techniques to help get this one narrowed down. All right, so let's start with GCFs, common factors. In the numerator, we can take a 3 out of all these terms. If I do that, I'm left with an x squared minus 6x plus 5, and that looks like something I could factor in just a moment. Let's deal with the denominator, though. It looks like I can take an 8 out of both of those. So that's x squared minus, let's see, 25. Let's go factor a little further. So let me bring down this 3. I don't want to lose that. And now inside this parentheses, I need factors of 5 that add up to negative 6. Well, there's 1 and 5, and that's about it. X minus 1 and x minus 5 will do the job. And now down here, let's bring down the 8. Don't want to lose that. And now this is the difference of squares, so I can use my plus minus shortcut, a plus b, a minus b. Square rooting these things, we have an x and a 5, so I can write x plus 5 and x minus 5. And it looks like the only common factors that we can cancel out are these x minus 5s, so let's do so. And now what's left over? Well, in the numerator, we have 3 times x minus 1, and in the denominator, we have 8 times x plus 5. And one thing you might have noticed on this problem and the other ones is that we're not bothering to distribute this. Fully simplified means you can actually leave this in factored form for the final answer. So that's it for this one. It takes a little while to get the hang of it, but I'm sure you'll be able to do future problems in a fraction of the time. Till next time, Mr. Sutton signing off.